Good morning. Welcome to Activity for Processing 2.22, which is designed for page 226, numbers 1, 2, 3, 4. Today I will be working on 4 examples in the order that would best assist you. So, example 1 will help you with number 1. Example 2 will help you with number 2. Example 3 will help you with number 3. And example 4 will help you with number 4. So they are chronologically in order so that as you watch a piece of the video, you can take notes, try the problem for yourself, and then look at the problem in the book and see, hey, let me try this, see if I can do it on my own. And then with your ability to go back and forth through the video, analyze different steps at your pace. And as you work through this, you can always reach out through live office hours or live class session, whatever it is that you need support with the videos, if you're watching them, if that's not enough. So without further ado, let's go ahead and jump into it. So example 1, once again, is going to help you with number 1. So our problem reads, x equals 36 over x. So you're going to notice these problems. First step is going to be a lot of cross multiplication. So the point of this objective, and I would argue the entire practice problem set 1 through 4, emphasize cross multiplication, and then the next few steps is where each of these 4 problems present unique opportunities for us to learn old math from the prior course or prior courses, and then take it from there. So that's kind of the objective here. It's not only cross multiplication and solving for x on both sides of a rational equation, it's all the steps necessary to get that accomplished. So let's go ahead and remind ourselves that this, on the left, value of x is a ratio with an invisible denominator of 1. We're going to go ahead and place that there so that we can carry out our cross multiplication. So we're going to multiply x times x. I'm going to write that down right here. And then over here on the right, we got 1 times 36. So on the left, if we multiply x times x, we get a product of x squared. On the right, we get 1 times 36, which is 36. Then we take the square root of the left, and we know that the index and the exponent are inverse operations. And if they are of equal value, they will cancel each other out, with us leaving only 36 on the right as the only thing we need to do. However, I'd like to remind my class that we take the square root of the left side of the equation, we're going to have to take the square root of the right side of the equation. Let me make this 2 a little more obvious here. It's a 2. Okay. Some people also call it the 2 root. That's totally okay. Now, when we take the square root of a number, let's go ahead and quickly remind ourselves we do get 2 answers, más o menos, plus or minus. So we get x equals positive 6 and x equals negative 6. And we can use this symbol that we have seen hopefully in the past to signify that there are 2 answers. Okay. So then what you would do next is actually plug those answers back in. You would plug in positive 6 first, see if that works. Then you would substitute in 6 and see if that works. Right? That's how you can verify that your answers are true and correct. All right. So now that you've seen this and hopefully understand the steps necessary to go from cross multiplication, distributive property, to taking the square root and finding the 2 solutions, now you are ready to go ahead and try number 1. However, if you're like, let me try this for myself real quick, go ahead, just pause the video, look away from the screen, try it in your notebook, write down this problem right here, and then see if you can do it on your own, and then hit play and see if you get the same solution, the same pathway to solving it. All right, let's go ahead and hop into example 2. Now, example 2 will help you with number 2. I'm not sure if the problem, I can't recall if the problem had a 1 here or not, but if it did or it didn't, does not matter. Just know that it's there, right? So if it didn't have it, put it there. If it did have it, great. They already gave it to you. So now we have a cross multiplication situation. You can see this one is very spicy. So let's go ahead and multiply x times x plus 3. Now you guys know that when I multiply a monomial times a binomial, this is how I like to show the product of the two values there. Okay, so I put the x outside, the x plus 3 over here to signify that I'm multiplying this x times this entire expression, x plus 3. So be careful with that, because what I see could go wrong here is we do that. So x times x is x squared and then plus 3. Okay, that's not what we want. This is going to make us sad. We want to make sure that we set it up in parentheses because we should know by now that we're going to see the distributive property in a moment, okay? I'll actually leave those little arrows there. So be careful when you do the multiplication with a expression of one term and an expression of two terms. Same thing over here, right? You got 1 times 8x minus 4. And I'm gonna draw these little arrows to signify I'm gonna do distributive property on the next step. All right, so let's do the distributive property. So x times x is x squared. X times 3 is 3x. On the right, we got 1 times 8x and 1 times negative 4. Now this part, this is where we've been having some fun, right? It's like, what do I do next? Well, what I like to see is that the highest degree term, x squared, is on the left. I'm going to bring everything to the left. And when I have a quadratic term, I like to see if I can get the right side equal to 0. So that's actually what I'm going to do right now. I'm going to just set it equal to 0 by doing the inverse operation of 8x as my first step. I'll take care of that 4 next. But right now, my goal is to get rid of 8x and negative 4 and turn this into 0 down here somewhere eventually. Okay, here we go. I should have done it in a different color. I don't know why I did that. The color does not affect the answer, ladies and gentlemen. I'm just being silly. Okay, go back to blue. So x squared, 3x minus 8x. This part right here, if you're like, wait, how do I do that? Just punch it into the calculator. 3x minus 8x will give you 5x. You can also think of it, if I have $3, but I owe someone $8, well, I still owe them $5 if I pay them back that 3, right? So, or the calculator would be fine. No problem with that. Okay, so now we got x squared minus 5x, which is the result of these two terms right here. 3x minus 5x, minus 8x gives us this. The 8x are gone, bye-bye. And all we have left is the negative 4. Be careful, because some people could be like, oh, all right, I got rid of this. And then just write 4 down here. No, 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 no. You got negative 4 left. So write negative 4 on the next line. All right. And remember, I want to get 0 here because whenever you have a quadratic, a degree 2x squared, it's very strategic to have 0 on the other side so we can factor in a moment. You'll see that happen in a moment, but just know that that's what my goal and why I'm doing this the way I'm doing this. I'm going to make a mistake on purpose right now. I've seen this happen a lot, especially on our quizzes when we do cross multiplication. I'd like to remind my class that 5x and positive 4, one is a variable, one is a constant. They are not like terms. So you do not just combine them because you feel like it. Don't do that. They are two different entities, two different types of values. So keep them and respect them as such by giving them their own space on the next line. Negative 5x is a variable, positive 4 is a constant. They do not combine. However, that's not an issue. They cannot combine. Keep them separate. And that's okay. All right. Now we see we have a quadratic set equal to 0. That's beautiful. Now we can actually factor. So we need two numbers, which if they add up, give us a sum of 4. And if they multiply, give us a product of 4. Sorry, I'm not sure if I said that right. Give us a sum of negative 5 and a product of 4. My apologies if I said that incorrectly. So one way I found useful, because some students are like, well, which numbers do I choose? There's so many. Well, write all the so many numbers out. Write them out. Right? And you see a negative here, so we're going to have to write some of the negative factors out. Okay. These are all multiples that will give us 4. So you're probably looking at this, you're like, dang, I have to write all those out? Yeah, so? So here we go. So we have to decide which one of these combinations. We have negative 4 and 1, negative 1 and 4, so yeah, so on and so on. Which one of these will give us negative 5 if we add them together? Okay. Sorry, I think I made a mistake here. Let me erase this last one. I got excited there. -1 times -4 gives me +4. Cool. I think I caught myself there. Okay. So 1 plus 4 is 5. No, I want -5. 2 plus 2 is 4. -2 plus 2 is 0. -1 plus -4, that should work, is -5. We are in business. There we are. -1, -4. Then I'd like to remind my students, we have two ways we can do this. We can do the shortcut method, which is totally okay in my class, where you just switch the sign and you get x equals 1 and x equals 4, right? X equals +1, x equals +4. But I'd like to remind my students, because it's going to come in useful on an upcoming example right now, that the reason we get those answers as a reminder is because we set each of the factors x minus 1 equal to 0 and x minus 4 equal to 0, which is how we got that answer and how we got this answer. Okay, I just want to remind you folks how that happened, okay? Because in a moment we're going to have to use this for a more complicated situation. So I'm a fan of shortcuts, but also know the thinking behind the shortcut, right? Know the long way of doing it, okay, and why it happens. If you use the shortcut, that's okay, but there are times where you cannot, you'll see in a moment, and you need to go back to your basics, your fundamentals, and remind yourself of how that came to be. All right, let's go ahead and hop to it. So ladies and gentlemen, now that you have all the work laid out, for example 2, go ahead. You can either try this problem again, or if you feel a little more comfortable, move on to number 2 on the practice problem set. Go ahead, clear this up. All right, let's move on to example 3. Example 3 will help you and give you some preparation for number 3. All right, so we have x over x squared equals 6 over x. Oh, this one's really fun. Talking about shortcuts, here's another shortcut that people do. All right, so I don't mean to sound bored right now, but we know this already. X times x is x squared, 6 times x. A little cross multiplication, y'all. I think we're okay with that now. But look, this is where the magic happens on this problem. We're going to divide the left side by x squared. We're going to divide the right side by x squared. This cancels out, but I'd like to remind my students that it does not disappear. When these two cancel out, you get a result of 1. So I'm going to put a little slash mark with an arrow saying this reduces to 1. X squared reduces to 1. I cannot tell you how many times we do this problem, ladies and gentlemen. And if we see this, I'm going to do it down here. Like, let's suppose this is the case. People will just do this. They're like, cool, it's 10. No, it's not 10. Let me scoot this over a bit. It's not 10. It's 10 times 1, which is 10, right? Some people say, oh, the x squares disappeared. Not really. It's just that, here, let me scoot over a bit more here. It's just that the x squared and x squared reduced to 1. So this is 10 times the result of these two items reducing to 1, which is 10. So yes, correct, it is 10, but I'd like to just kind of correct your thinking here. It's not 10 because these two just disappeared. No, it's because they reduced to 1, and 10 times 1 is 10. Just want to remind you guys of that. Why is that important? Why am I talking about that? Because, ladies and gentlemen, I'm going to write that down right here and right here, right? How many of us would have written 0 right there? Right? It's not 0. Okay, so now we run into another issue. Oh no, oh no, oh no. We got 1 equals 6. Ladies and gentlemen, that's not possible. 1 cannot equal 6. We're going to scratch that out. And we know when we have the left and the right side of an equation not equal to each other, that is an untrue statement. And in math, when we get an untrue statement, we can write no solution. That's the trick to this one. See? That part, analyze that part, think about that part, and then apply it to number 3, all right? So this one actually is the one that requires the least amount of steps out of the problem set, I believe. But it's the one that could just really trip you up because you're getting ahead of yourself. And go ahead and try this problem out, right? You can go ahead and get ahead of yourself. Oh, cool, I'm going to just start canceling stuff out willy-nilly and just you get so excited. And then you forget the fundamentals, right? But it's okay. It's easy to get excited because we get these long problems and then out of nowhere we get this short problem. But little do we know, it's just trying to throw us off. But do not fall into that trap. All right, example 4, which will help you with number 4, is 10x squared plus 24x over 5x cubed equals 4 over x. If you're looking at this, you're all like, wow, that's a beast of a problem. It is, but that's why they saved it for last. All right, let's go ahead and do some cross multiplication. Now you will see, like we did, what was it? Example 2, be careful. We have a monomial and a binomial. When you do cross multiplication, I'm gonna write the monomial outside and the binomial inside. I cannot say binomial right now for some reason. And then we're gonna do the same thing over here. 4 times 5x cubed. Let me double check this. This is on camera. It is not. I had an inkling there. Okay, now let's go ahead and apply that distributive property. Okay, so we're gonna multiply x times 10x squared, which is 10x cubed. Next, we're gonna multiply x times 24x, which is 24x squared. We're gonna do the same thing. We're gonna go move over to the right side of the equation over here. Use the distributive property, monomial times monomial. We got 20x cubed. All right, cool. We have an equation. Now we notice that the highest degree is over here, x cubed. X squared is cool, but this time we got a bigger boy on the block, right? We got x cubed. So we got to go ahead and do ourselves a favor. I'm going to go ahead and move this 20x cubed over here. I can do that, or I can move this entire expression over here. Now this one's a little tricky because on the last problem, I think it was example 2, I was like, hey, let's just move everything to the left. But my preference here, you can do that. You can definitely do that. But my preference here is I like to keep the highest degree positive if I possibly can. So if I were to do minus 20x cubed, which I'm not going to do, but I'm going to show you, minus 20x cubed, I'm going to get negative 10x cubed here. That's fine. That's okay. It's not going to stop you from solving the problem. But something for me is just like, I don't feel like factoring and dealing with negatives, honestly. So here's what I'm going to do. I'm going to subtract 10x cubed from both sides. And I know a lot of us feel discomfort here. We're all like, well, how was I supposed to know that? You weren't. It just comes with experience. I've been doing this for X amount of years, ladies and gents. And like any great art, the longer you do it, the more proficient you become, the more comfortable, and the more you can see ahead, right? So either way, back to this. So now we got 10x cubed and 24x squared. And then many of you are like, oh, I can start dividing and stuff. No, don't. Slow your roll, slow your roll. What we're going to do here is we're actually going to subtract 24x squared from the left side and from the right side. So you're probably thinking to yourself, what? This is not good. Why would you do that? Okay. So here's what we got. We're going to set this up here. And I know some of you were like saying, oh, is this negative 14x cubed or negative 14x squared? It's neither. These are not like terms right here. X cubed and x squared are not like terms, so keep them separate. So now we have a cubic function set equal to 0, and we can actually start factoring here. So you're getting the hint that when you set a polynomial, whether it's quadratic or cubic, equal to 0, some factoring ensues, right? It's coming up. So what we're going to do here is we're going to look at 10 and 24 and think, what is a common multiple of 10 and 24? What can I divide 10 that I can also divide 24 by? That number should be 2. Now, here's what I'm going to do. This is the tricky part to explain. I got x cubed and x squared here. I need to factor out as much as I can. So I can take 2 x's from here. Let me draw this. I think this is going to help here. I'm going to take 2 x's away from here. Boop, boop. Okay? So there's 3 x's there. I'm going to borrow 2 of them. I'm going to put them here. I'm going to do the same thing here. There's only 2 x's. I'm going to borrow 2 of them and put them out here. I'm going to factor them out. Boop, boop. So there's one left here on the left term, and there's none left over here, so I'm not going to write anything there. All right, now I'm going to go ahead and do this out loud. 10 divided by 2 is 5. X cubed divided by x squared is x. Okay, so that's one way of thinking about it, like what I did the scratching out of stuff. Or we can do it this way, x cubed over x squared, which is x. And then over there, let's move on to the next one. 24 divided by 2 is 12. And x squared divided by x squared, which I'll do right here, is 1. Which I'm not going to write right there. I'm just going to keep it that way. All right. Now we need to solve for x. And this is why in example 2, I went over how you do that. So we're going to set up our 2 equations. We got 2x squared equals 0. We're going to divide both sides by 2. X squared. You know what I'm gonna do? I don't like doing this, but I mean, worst case scenario, you can just rewind, right? I'm gonna go up here and solve the rest of this problem up at the top. I just ran out of space, so that's what I have to do. So 2x squared equals 0. We're gonna divide both sides by 2. So remember, I'm setting up this part equal to 0, and next I will do this where I set up 5x minus 12 equal to 0. I'll do it over here in a moment. So right now I'm solving for x for this equation, because I am going to get two solutions, one for this part, one for this part. Okay, so I'm going to take the square root of both sides. We seen this just a moment ago, so not too long ago. Okay, cool. So x equals 0. That's going to be our first solution. You can put plus or minus 0, but we know the story behind 0. It's not plus nor minus. It's a neutral number. So we're going to just leave it like that. So that's one of our answers there. All right, now we're going to do the other equation, 5x minus 12 equals 0. So right here, you can tell already, wait, how am I supposed to flip the sign on this one? It's not as easy. It's not x equals 12 like the other problems, because I have a 5 here all of a sudden. Well, that's why shortcuts don't always help. And there actually is another shortcut for this, which I'll show you some other time, but that's for another day. Or if you guys want, just come to the live session and I'll show you how to do it. There is a shortcut. And this is just a two-step equation, which is not too much of a big deal here. Yeah, I'll show you the shortcut right now. I'm not going to speak on it, but I'll just circle what I need to circle. Or put a little check here. See if you can figure out the shortcut for yourself, okay? I'll let you play with that. All right, so this is example 4. I'm sorry right now we can't look at the steps or whatever, but you can always rewind the video. But what I wanted you to just see is how to solve each of these two, rather than just me saying, oh, x equals 0 and x equals 12 over 5. You figure it out. Now I wanted to walk you through the steps, so when you go into number 4, you can kind of retrace what I did here and apply it there. All right, ladies and gents, good luck on problems 1, 2, 3, 4, which once again correlate to examples 1, 2, 3, 4, which we did here. Without further ado, good luck, have fun, may the force be with you.